Hi, I'm Charlie Calvert, and I'm here to create a short video on the first section of the first chapter of Joyce Farrell's book, An Introduction to Object-Oriented Programming. And I'm just going to occasionally give a little commentary on sections that she's written, just to add my point of view so that you'll have 2 points of view on the material. What she does a great job, and then you'll hear my point of view. So hopefully between the two, the materials start to make sense to you. So she starts out here talking about the 3 layers that are involved in a computer program. She says there's a hardware layer. That would be your physical machine, like a laptop or a desktop machine, something made by HP or Dell. Then on top of that, there's an operating system. In our case, that's Windows. And then on top of that, there are applications. Now, applications have a very broad category. On a typical operating system, there'll be applications like Notepad or Word or the Internet Explorer. And then we can build applications using our tools, in this case, C#. Okay, so 3 layers: hardware, operating system, applications. Now, applications are built with computer languages. There are 2 broad categories of computer languages. There are human readable computer languages and non-human readable computer languages. Of the non-human readable computer languages, one is called binary data, which is zeros and ones, and that's very much the native language of a computer. On top of that, there's another language called assembly, which is very, very low level. Some people can read it, but it's very difficult to read. It's a non-human friendly language. Then on top of that, they start building what are called high-level computer languages, which have English-like traits. Okay? Now, there are different kinds of high-level languages. There are low high-level languages and high-level languages. Okay, there's a range of high-level languages. One very common language is called C or C++, and that's considered a fairly close to the metal high-level language. And you might build an operating system out of C or C++. You might use some assembly language mixed in there too. Then there are languages which are abstracted a little further from the hardware, and C# is one of those. It runs inside a virtual machine. So, and we'll discover this and talk about this later, but you might as well be introduced to it now. There's the hardware, there's the operating system, then there's something called a virtual machine. In our case, it's the .NET virtual machine. And it's like a machine, a computer built in software that runs on top of the operating system. And it helps protect us from making errors that would be potentially catastrophic to the stability of the operating system. So we run our programs as C# programmers. We run inside these virtual machines, which give us sort of a safety net, which protects us from doing too much damage to the operating system if we make an error. The virtual machine also has another wonderful trait. It helps manage the memory of our programs for us. And again, you don't need to understand the details of that right now, but you don't need to think much about memory management. If you were writing in C or C++, you would keep having to think specifically about allocating and deallocating memory on the machine. You would say, I want to use this part of the RAM of the machine for this purpose, and now I'm through using that piece of it. I'm done with it. I want to delete it. You never have to worry about that in a high-level language like C#, which runs inside a virtual machine. So that's a very nice thing to have. So after she's talked about generally about programming languages in computers, she then starts talking about the structure of a computer programming language. And she talks about 3 different things: keywords, which I think maybe there I would say she introduced that concept a little soon. We're still on a very high level here. We're just talking about the 2 broad categories of information inside a computer program. And one is syntax and the other is logic. To better understand the difference between syntax and logic, let's move over to an entirely different domain. This is the domain of Tic Tac Toe. There is a defined syntax for Tic Tac Toe, just as there are defined syntax for C#. Both C# and Tic Tac Toe exist inside a closed system with a defined syntax. We know the syntax for Tic Tac Toe. You have a board with 9 squares in it, and inside those squares you draw a series of X's and zeros. If you were to draw a large red triangle on your board, you would be violating the syntax of Tic Tac Toe. You don't draw big red triangles, instead you draw X's and zeros, and then you use logic to try to win the game. In C#, we have a clearly defined syntax. Let's suppose we wanted to add two numbers together. Well, the first thing we discover is that inside C# there are two broad categories of syntax. There's a syntax for declaring data, and there's a syntax for performing operations on that data. Let's begin by declaring data that we would use when adding two numbers together. We'll begin by declaring the type of our data, and you don't need to worry about types. We'll talk about types later. We give our data a name, in this case operand A, and again you don't need to worry about names at this stage. We'll talk about naming later. And we've assigned values 5 and 6 to these two pieces of data. Now, let's see if we can't perform an operation on that data. So we've moved from the realm of declaring data, one part of the syntax, to the realm of declaring operations on that data. We'll begin by declaring yet another piece of data, and now we're going to perform an operation on the two pieces of data that we declared earlier. Now, we've written something that seems very sensible. We said result equals operand A and operand B. That sounds like a great way to add two numbers together. But as you can see, the compiler's not happy. It doesn't like the syntax that we've used. Now and you can see that because of the red squiggles under the names and the errors that have showed up down here in the error list. If you wave your mouse under it, you can see yet another reference to the error we've made. So let's fix our syntax. How I fix it is not important right now. The point is, I know the syntax of C#, and so I can fix the error. Now, I've made some changes. I'm obeying the rules just like we obeyed the rules by putting X's and zeros in the right squares in Tic Tac Toe. The red squigglies have gone away. The errors down here have gone away. Life looks good. Okay, let's now try to write out the results that we've created and see if we're actually getting the results that we wanted. So we use console.writeLine to write out the variable that contains the result of our operation. So we'll go ahead and control F5 to run the program, and lo and behold, we're getting 4. Now, 5 plus 6 doesn't equal 4. Our syntax is correct, but there's something wrong with the logic of our program. The error that we've made here is that we have used the AND operator where we wanted to use the plus operator. Now let's run the program again, control F5 to run the program. This time we see that 5 plus 6 equals 11, and our logic is correct. We saw two different kinds of problems you can have with your program. Syntactical errors, like putting a big red triangle in the middle of the board in Tic Tac Toe, and logical errors like losing a game of Tic Tac Toe, okay, where we got the wrong result. All right? Logic, syntax, the two primary elements inside of a computer language. All right, that's all I want to say now, and we'll go ahead and we'll end this discussion of the programming section in Joyce Farrell's book.